In the 1990s, tractors became more powerful, but not always more dependable. As electronics increased, so did failures. That's why the engines that stood out weren't just strong, they were simple, proven, and easy to fix. These are the 15 most reliable 90s tractor engines ever made. Number 15, MWD 401.81 turbocharged diesel. In the early 1990s, Steyr introduced the 9000 series tractors to serve mid-sized farms across Europe. Among them was the Steyr 9078, powered by the MWM WD4 01.81 diesel engine, a turbocharged four-cylinder that prioritized efficiency and mechanical stability over electronic complexity. Built between 1993 and 1995, it became known not for raw output, but for its dependability across seasons and tasks. Displacement measured 4.2 liters, equal to 253.6 cubic inches. This engine delivered 78 horsepower at 2,300 revolutions per minute, with peak torque near 220 pound-feet at 1,500 revolutions per minute. But what mattered most was the consistency of that output under actual working conditions. The foundation of its reliability lay in its mechanical simplicity. The WD4 01.8. One avoided early electronic systems, which were still prone to failure in the 1990s. Instead, it used a mechanical fuel injection system that delivered stable fueling, regardless of fuel quality or temperature. That translated to fewer breakdowns, easier field diagnostics, and less downtime. Cooling was also a strong suit. With a liquid-cooled system, the engine maintained stable operating temperatures during extended PTO work or summer tillage. Overheating was rare under normal use, supported by an efficient radiator and well-sized cooling channels, an important factor in extending component life. Torque arrived early and stayed steady, allowing heavy implements or trailers to be pulled without excessive revving or frequent gear changes. This steady delivery reduced stress on the drivetrain and kept fuel consumption efficient. What ultimately made the MWD 401.8 so dependable was its ease of maintenance. Service points were easily accessed, and repairs didn't require special tools or electronic diagnostics. Parts remained widely available through Steyr and MWM's aftermarket networks. Many of these engines still operate today, often exceeding 10,000 hours without major overhaul. Failures typically resulted from neglect, not engineering flaws. Built with practical design, steady output, and minimal complexity, the MWD4 01.8 is among the most reliable tractor engines of the 1990s. Number 14. Ford New Holland Genesis 7.5-liter. When the Genesis series was launched by New Holland in the early 1990s, it marked a turning point for mid-horsepower tractors. Designed and manufactured in Winnipeg, Canada, the Genesis 8870 model introduced a power plant that stood apart for its long-term dependability, the Ford Genesis 7.5-liter diesel engine. This inline six-cylinder, turbocharged engine was more than just a step up in performance. It was built to handle larger implements and longer workdays without becoming maintenance-heavy. Unlike the increasingly electronic power plants of its time, the Genesis engine prioritized mechanical reliability and field serviceability. It was engineered for consistency, not complexity. Displacement came in at 7.5 liters, equal to 456 cubic inches, with output rated at 210 horsepower at 2,100 revolutions per minute. These figures placed it within the high performance range for the decade, but its true strength was how reliably it delivered under load. One key reason operators trusted this engine was its early torque delivery and wide usable power band. With peak torque low in the RPM range, tractors powered by this engine could manage tough soil or transport large loads without excessive gear changes. This smoother operation helped conserve fuel and reduced drivetrain stress. Cooling was another strength. With a 25-liter coolant capacity and a belt-driven fan, the system maintained temperature balance under continuous use. The oil system, holding 5.5 gallons, ensured lubrication remained stable through prolonged operation. The Genesis engine also earned points for practicality. Components like filters and injectors were easily accessed, reducing service times. The mechanical injection system tolerated poor fuel quality, and minimal electronics meant fewer failure points. In long-term operation, many units crossed 8,000 hours without major overhaul. Failures were rare and typically external. With only routine upkeep, these engines delivered season after season. The Genesis 7.5-liter diesel wasn't about flash. It was about showing up, holding steady, and staying in the field. And that's exactly what it did. Number 13, Zetor 5201. Zetor introduced the 5213 model in the early 1990s with a clear purpose: build a compact tractor that could deliver dependable performance in orchards, vineyards, and small fields. At the core of this machine was a power plant that did more than just run. It endured. The Zetor 5201 three-cylinder diesel engine became known not for flash or output, but for its ability to stay reliable in settings where tools and time were both limited. One of the first things that made this engine dependable was its straightforward design. Displacement came in at 2.7 liters, equal to 164.6 cubic inches, and the three-cylinder configuration meant fewer internal parts and fewer potential failure points. Fewer cylinders did not mean less capability. It meant less to go wrong. Power was modest but steady, rated at 44.4 horsepower at 2,200 revolutions per minute. But more importantly, torque arrived early in the power band and held steady across working speeds. That allowed operators to reduce shifting and stay in control while working between rows or managing light implements. Fewer gear changes also meant less wear on the drivetrain and smoother fuel consumption. Cooling was another strength. With a coolant capacity of 9.5 liters, the system stayed within safe temperatures even during extended use. Operators noted that the engine rarely overheated, even in warm climates or under back-to-back work sessions. The engine also featured a simple mechanical injection system. This not only made fueling consistent, but also more tolerant of dusty conditions and varied fuel quality. No electronics meant fewer unexpected failures and easier diagnostics when problems did occur. Fuel capacity was 10.3 gallons, enough for long field sessions without frequent refills. Service points, filters, injectors, valve covers were placed for quick access, so downtime was minimal. The Zetor 501 didn't earn its reputation through complexity or innovation. It earned it through dependability, by showing up, running clean, and asking for very little in return. That's what made this engine one of the most reliable of its decade. This is just the beginning. What's coming next powered harvests, hauls, and hard days without failure. If that's the kind of reliability you respect, hit like, subscribe, and stay locked in for what's ahead. Number 12. Kubota Fi 3300-T-E2B. By the late 1990s, Kubota had earned a reputation for building engines that outlasted the equipment they powered. But in industries where uptime was critical, like agriculture, construction, and municipal work, the demand for a compact diesel that could operate across thousands of hours without failure was growing. The result was the Kubota Fi 3300 TE2B, part of the company's V3 series, designed not for innovation's sake, but for consistent performance where it mattered most. At the heart of the 3300 TE2B's reliability was its mechanical clarity. This four-cylinder, vertical, water-cooled diesel engine followed Kubota's long-standing principle: fewer complications, fewer failures. Displacement measured 3.318 liters, equal to 202.5 cubic inches, with a bore and stroke of 98 by 110 millimeters. Instead of relying on early electronics, the engine used a mechanical fuel injection system, which proved tolerant to low-quality diesel, field dust, and moisture. It wasn't advanced, but it was dependable. Power output reached 83 horsepower at 2,600 revolutions per minute. But more important was how that power behaved. Torque arrived low in the RPM range and remained stable across a wide band, which reduced shifting, eased operator input, and lowered stress on connected machinery. This smooth delivery helped protect both the transmission and PTO components over time. Temperature control was another reason the V3300 TE2B proved so durable. A pressurized cooling system and belt-driven water pump worked in tandem to hold operating temperatures steady, even during prolonged fieldwork or high-rev stationary use. Combined with a lubricating oil capacity of 13.2 liters, or 3.49 gallons, the engine maintained steady internal pressures, preventing accelerated wear. What truly earned the V3300 TE2B? Its reputation, however, was how rarely it asked for attention. Oil changes, filter swaps, and valve inspections were accessible and straightforward. There were no sensors to reset, no diagnostic computers required, just maintenance and results. Years later, many 3300 TE2B-powered machines are still in the field, not because they're new, but because they refused to quit. Number 11, Perkins 3.9-liter diesel. By the late 1980s, the utility tractor market had changed. Operators wanted machines that were not only powerful enough for daily tasks, but also simple to maintain and built to last. Massey Ferguson responded with the 390T, a model produced from 1989 to 1997. At its core was the Perkins 3.9-liter turbocharged diesel, an engine that became known for running season after season with little more than routine care. What made this engine reliable wasn't just how it was built, it was how it was used. The inline four-cylinder layout, combined with a cast-iron block and gear-driven components, provided the mechanical stability needed for long hours in the field. Its turbocharging system wasn't designed to push peak power. Instead, it delivered torque at lower engine speeds, which allowed operators to run implements without stressing the driveline. This smoother power delivery helped reduce wear across the transmission and final drive. Fuel delivery came from a mechanical direct injection system. It was simple, consistent, and not dependent on electronics. That meant the engine could tolerate poor fuel quality, rough storage conditions, and extended intervals between servicing. Many operators valued how easily the engine could be bled and restarted, even after long periods of downtime. Thermal control was another factor in its longevity. With a large radiator and liquid-cooled design, the engine maintained steady operating temperatures even under full load. A total coolant capacity of 15.5 liters ensured there was enough volume to keep internal temperatures in check during PTO operations or summer tillage. The oil system was equally robust, circulating over 2.03 gallons of oil, more than enough to maintain pressure during long field sessions. But perhaps the most defining trait of this engine was its serviceability. From filter changes to valve adjustments, maintenance could be done quickly with basic tools. No diagnostics, no codes, just straightforward mechanical systems that kept running. Engines like the Perkins 3.9-liter didn't rely on complexity to last. They relied on smart engineering, strong components, and the ability to handle tough conditions without complaint. And that's why decades later, many are still in the field, doing exactly what they were built to do. Number 10, Deutz BF 6M1013M CP. When Deutz introduced the BF6 M1013 MCP, it wasn't aiming to break records. It was aiming to eliminate downtime. Built for heavy-duty tractors and equipment, this six-cylinder turbocharged diesel engine was engineered to perform long hours under full load without compromise. And that focus on consistent reliability made it one of the most trusted engines in its class. At the foundation of its endurance was a displacement of 7.2 liters, equal to 439 cubic inches. The bore and stroke, 108 by 130 millimeters, gave the engine a long stroke configuration designed for sustained torque and reduced internal stress. This setup was not just mechanically balanced, but also forgiving during high-load operations. What truly defined this engine was how early and reliably it delivered torque. In its standard configuration, the engine produced up to 234 horsepower at 2,300 revolutions per minute, with peak torque reaching 630 pound-feet at 1,400 revolutions per minute. That meant usable power arrived quickly and stayed consistent, allowing for smoother performance with less gear shifting and fewer strain cycles on the driveline. The fuel system played a major role in its dependability. Whether equipped with a mechanical inline pump or an electronically regulated variant, the system was built to handle a wide range of fuel conditions. In remote or harsh environments, this tolerance meant fewer filter blockages and fewer injector failures, two common causes of unexpected engine shutdowns. Cooling was another area of strength. A water-cooled system, supported by charge air cooling, helped keep operating temperatures stable during long days in hot weather or under full PTO load. Thermal stability preserved oil quality and prevented accelerated wear on pistons and cylinder liners. Serviceability was built into the design. All routine maintenance points were located on one side of the engine, making field service quick and accessible. That not only reduced downtime, it encouraged more consistent maintenance. The BF6 M1013 MCP did not rely on gimmicks to earn its place. It relied on structural strength, fuel tolerance, thermal control, and a reputation built on thousands of hours of steady performance. That's what made it reliable, and why it remains respected across industries. Number 9. Sisu Diesel 420DS. By the early 1990s, Valmet was gaining ground in the mid-size utility tractor market, but it wasn't styling or comfort that made the 6400 stand out. It was the performance of the Sisu Diesel 420 DS engine that built its reputation. This engine did not aim to push boundaries on paper. Instead, it proved its worth in the field through consistent output, mechanical strength, and long-term reliability across thousands of working hours. At the center of its design was a four-cylinder diesel layout with a displacement of 4,428 cubic centimeters, or 270 cubic inches. That sizing allowed for a compact engine with strong mid-range torque and minimized fuel consumption, making it well-suited for mixed-use tractors that operated both in the field and on the road. Operators often noted the engine's balance between efficiency and usable grunt, particularly under partial load. Rated at 75 horsepower, the 420DS delivered steady performance without relying on turbocharging. That natural aspiration became an asset in the long run. Without a turbo system to maintain or replace, the engine's service life remained straightforward and its power curve predictable. For PTO-driven applications like mowing or baling, the smooth delivery was a clear advantage. The engine was also engineered with longevity in mind. A wet sleeve block design allowed for straightforward rebuilds, cooling was handled by a well-sized radiator system, and oil circulation remained stable under extended load. With oil pressure maintained even during long tillage runs, wear across the crank and cam bearings remained low. Fuel injection was mechanical, consistent, and well-matched to the engine's duty cycle. Many examples of this engine are still in service today, with owners reporting well over 10,000 hours before requiring major overhaul. In restoration circles and on working farms alike, the Sisu Diesel 420DS has become known not for peak figures, but for consistent, repeatable output and minimal unplanned maintenance. That combination of stable mechanics, durable internals, and ease of service is exactly why this engine earns its place among the most reliable of the decade. Number 8. John Deere PowerTech. John Deere set its sights on building tractors that could deliver modern performance without compromising long-term durability. At the center of that mission was the John Deere 7710, powered by the PowerTech 8.1-liter diesel, an engine that earned its place through years of dependable operation under real-world pressure. The PowerTech engine in the 7710 was built for sustained agricultural workloads. With 6 cylinders and a displacement of 8.1 liters, equal to 494 cubic inches, it struck a careful balance between torque, temperature control, and component longevity. Rated output reached 145 horsepower, with peak torque approaching 535 pound-feet. But these numbers only told part of the story. What set the PowerTech engine apart was how it sustained those figures across long hours of operation. In heavy draft work, during baling, or while running PTO-driven implements, the engine delivered steady pull with minimal throttle fluctuation. Operators often reported that the engine held RPM under load better than comparable models, reducing downshifting and keeping field operations smooth and uninterrupted. The cooling system was sized to handle high thermal loads. An oversized radiator and hydraulic fan ensured stable temperatures, especially when pulling at full drawbar load during hot weather. Just as critical was the oil system, which carried over 21 quarts of fluid. This helped preserve oil pressure during long PTO sessions and extended intervals between changes. Fuel efficiency was also notable. With a clean-burning mechanical injection system and a matched turbocharger, the engine maintained optimal combustion, even under variable fuel conditions. Service intervals were clearly defined, and access to key components was straightforward, supporting in-field maintenance without unnecessary downtime. Long-term reliability was no accident. Deere designed this engine with rebuildability in mind. Many 7710 tractors are still running today, frequently surpassing 10,000 operating hours with only routine maintenance. Rebuild kits remain available, and the engine's wet sleeve construction simplifies overhaul. In the field, reliability is measured in seasons, not specs, and the PowerTech engine in the 7710 earned its reputation by showing up, spring to fall, year after year, without asking for special treatment. Number 7. International DT 530E. In the mid-1990s, reliability was facing a new kind of test. Tractors and work trucks were moving toward electronic controls, stricter emission standards, and tighter fuel regulations. Amidst these changes, Navistar introduced the DT530E, an engine designed not just to meet modern demands, but to do so without compromising the durability that defined its mechanical predecessors. This inline 6-cylinder diesel was built on the long-proven DT block platform, but introduced electronically controlled fuel delivery through a HEUI abbreviation of Hydraulic Electronic Unit Injector System. That addition brought precise fueling and improved cold start behavior, especially in variable climates. But critically, it was integrated without sacrificing the simplicity of routine servicing or internal reliability. Displacement measured 8.7 liters, equal to 530 cubic inches. The block retained wet sleeve architecture, a feature valued by operators and technicians for its rebuildability and consistent thermal balance. In the field, this meant fewer overheating issues under full load and easier maintenance when rebuilds were eventually required. Power output typically ranged between 275 and 300 horsepower, depending on calibration. But the true measure of its real-world dependability came from its torque delivery. With a flat torque curve arriving low in the RPM range, the DT530E offered steady, usable force without surging or stalling, a critical advantage in draft work and heavy transport. Temperature regulation was handled through an air-to-air aftercooler and a belt-driven cooling fan. This setup allowed the engine to maintain oil and coolant stability during extended PTO operation or hauling at sustained RPM. The oil capacity exceeded 6 gallons, supporting long drain intervals without degrading pressure. What made the DT530E exceptional was how it carried forward old-school mechanical strength while adapting to new-era electronics. It didn't just survive the transition, it led it. With tens of thousands of these engines still operating across farms and construction fleets, its record has been set not by advertisement, but by hours on the clock. It delivered long-term reliability, not as a claim, but as proof, in metal and time. Number 6. Cummins 6BT. When Cummins developed the B-Series engines in the mid-1980s, they were not designed as a short-term solution. They were intended to serve across industries, agriculture, construction, transport, with minimal compromise and long-term dependability. Among them, the 6BT, also known as the B5.9, became the cornerstone of that reliability legacy. It was designed with mechanical simplicity at its core. This inline 6-cylinder diesel offered a robust foundation, a cast-iron block, direct fuel injection, and gear-driven components that eliminated failure-prone belts. Displacement measured 5.9 liters, or 361 cubic inches, placing it in the optimal range for mid-duty agricultural applications. Yet what defined this engine was not output alone. It was how consistently that output held under pressure. Rated power varied depending on configuration, but typical outputs range between 120 and 175 horsepower. More importantly, torque delivery was accessible and predictable, with figures reaching upwards of 400 pound-feet at relatively low RPM. This meant tractors equipped with the 6BT could maintain steady traction and power through tillage, loader work, or transport tasks without excessive shifting or revving. Reliability was also supported by thermal and lubrication systems built for field longevity. With a large volume oil sump holding nearly 4 gallons and full pressure lubrication throughout the block, the engine retained oil stability over long operating hours. A belt-driven cooling fan and high-capacity radiator ensured consistent temperature control under full load. What further distinguished the 6BT was its repairability. The mechanical injection system was not sensitive to electronic failure or inconsistent fuel quality. It responded well to regular servicing, and when overhauls became necessary, wet sleeves and wide parts availability made them cost-effective and straightforward. This engine earned its reputation not in isolated cases, but across decades of continuous operation in utility tractors, skid steers, and irrigation pumps. It was never designed for show, but for work, and it kept working. The 6BT didn't need digital controls or complex tuning to prove itself. It just needed time, and it delivered 1 hour at a time with no shortcuts and no excuses. Number 5. Iveco 8065.05 inline-6 diesel. In the early 1990s, Fiat was looking to modernize its high-horsepower tractors without abandoning mechanical dependability. That goal led to the adoption of the Iveco 8065.05, a 6-cylinder diesel that struck a careful balance between power, serviceability, and real-world longevity. Found in the Fiat F115 and other models of the period, this engine became a quiet benchmark for reliability across Europe and beyond. Displacement was measured at 6.0 liters, or 367 cubic inches, which placed it in the mid to upper range of the utility and row crop tractor category. While horsepower ratings varied by application, the version used in the Fiat F115 delivered approximately 115 horsepower, with a torque profile designed for steady fieldwork. Its torque curve was broad and flat, making it especially well suited for heavy draft tasks and PTO-driven implements. What made the 8065.05 notable was its mechanical configuration. It used a direct injection system and relied on a robust cast iron block, ensuring structural integrity under load. The design emphasized service access, with external injection components and simplified valve gear, making routine adjustments straightforward. This mattered in regions where field maintenance was more common than shop overhauls. The engine's cooling and lubrication systems were also engineered with endurance in mind. A high-capacity radiator and belt-driven fan kept operating temperatures consistent under prolonged load, while the full-flow oil system maintained pressure even during extended operation. With regular oil and filter changes, the engine could routinely exceed 10,000 hours before major work was required. Operators valued how the engine responded to inconsistent conditions, variable fuel quality, dusty environments, long idle periods with no drop in performance. Its mechanical simplicity helped insulate it from electrical faults, which were becoming more common in newer models. While it never drew attention in sales brochures or headlines, the Iveco 8065.05 built its name the hard way by staying in the field and staying reliable. For large acreage farmers needing dependable output and low maintenance overhead, this engine delivered quietly, effectively, and over the long haul. Number 4. Perkins Phaser 1004.4T engine. By the early 1990s, Perkins had already built a reputation for dependable mid-sized agricultural engines, but the Phaser series marked a deliberate step forward. Among the most notable in this lineup was the 1004.4T, a turbocharged four-cylinder diesel introduced to provide a reliable upgrade path from older naturally aspirated designs. It was aimed squarely at tractors that needed more torque and efficiency, without sacrificing serviceability or long-term durability. This engine powered a wide range of machines across brands, including Massey Ferguson's high-use mid-range tractors. Displacement was measured at 4,000 centimeters cubed, or 244 cubic inches, and the turbocharging system was optimized for farm work, not just peak output. Horsepower output typically landed around 90 horsepower, but the engine's true strength was how predictably it delivered torque through long working hours. The Phaser 1004.4T used direct injection and a swirl combustion chamber design that improved both cold starts and combustion efficiency. These upgrades made the engine cleaner and more responsive without introducing unnecessary complexity. The crankshaft was forged steel, and the block was cast iron, standard decisions, but ones that pointed to endurance rather than cost savings. The lubrication system played a key role in the engine's longevity. A full-flow filtration system and high-volume oil pump maintained pressure even during extended PTO work or tillage. Combined with a properly sized radiator and water pump, the engine held steady thermal conditions without drifting into fatigue under load. Real-world performance backed the engineering. Farmers consistently reported 10,000 hours or more before a rebuild was necessary, with many engines only requiring top-end service due to predictable valve wear or injector aging. Parts were widely available, and the mechanical fuel system allowed continued operation even under poor fuel storage conditions. The Phaser 1004.4T earned its place not through innovation alone, but through a consistent pattern of field-proven durability. It performed in various climates, across continents, and under different brands, all with the same quiet reliability. For operators who needed assurance that their engine wouldn't become the weak link, this Perkins diesel consistently delivered. Number 3. Navistar DT466E. When Navistar introduced the DT466E in the mid-1990s, it represented more than just a diesel upgrade. It marked a turning point in electronically controlled tractor engines. Designed as a follow-up to the highly respected mechanical DT series, the 466E brought durability into the digital age without compromising the mechanical integrity that made its predecessors dependable. The engine was built around a robust wet-sleeve inline-six architecture with a displacement of 7.6 liters, equal to 466 cubic inches. This configuration allowed for both long-term serviceability and thermal control during high-load conditions. Power output typically ranged from 175 to 230 horsepower, with torque figures climbing near 600 pound-feet. depending on application and calibration. Where the DT466E stood out was in how seamlessly it merged mechanical strength with modern electronic control. Its high-pressure oil rail system powered the injectors using pressurized engine oil, eliminating the need for traditional injection pumps. This electro-hydraulic HEUI system not only improved fuel atomization but also enabled more precise control of timing and combustion across varying loads and speeds. Reliability came from more than just specs. The engine block was overbuilt, the internals were forged, and the cooling and lubrication systems were designed for continuous duty operation. Field units routinely passed 10,000 hours with minimal downtime, supported by strong aftermarket parts availability and diagnostic tools. The DT466E was not just an evolution, it was a benchmark. It proved that electronically managed diesels could still hold up in rugged agricultural environments. Decades later, its continued use in tractors and equipment is proof of the engine's long-term viability under real-world conditions. Number 2, Sisu Diesel 620DS. You got that? During the transitional period of the early 1990s, Finnish manufacturer Valmet, under the Sisu Diesel banner, delivered one of the most respected mid-size agricultural engines in Europe, the 620DS. Built to power tractors like the Valmet 8400, this six-cylinder diesel engine was designed with endurance in mind, not experimentation. At a time when electronics were creeping into engine design, the 620DS kept its priorities fixed on serviceability, simplicity, and sustained output. With a displacement of 7.4 liters, or 452 cubic inches, this engine sat in the ideal range for medium to heavy-duty farm work. It produced between 120 and 140 horsepower, depending on configuration. But its strength lay in its broad, usable torque band, one that provided reliable pulling power across various soil conditions and implement demands. Internally, the engine was constructed using a full cast-iron block with wet sleeves, allowing for quick and affordable in-frame overhauls. The inline pump fuel system remained mechanical and dependable, resisting wear and contamination from inconsistent fuel quality, an issue common in remote agricultural zones. Its naturally aspirated design was later followed by turbocharged variants, but all versions shared the same core trait: consistency under pressure. The cooling system and oil circulation were scaled to match prolonged operational hours. It was not unusual for the 620DS to exceed 10,000 hours, with only basic maintenance, making it a favorite among operators looking for minimal downtime. Components were accessible, parts support remained strong, and rebuilds were straightforward. The engine's continued use across Nordic fields, restoration farms, and forestry equipment stands as proof. The 620DS earned its place through quiet, uncompromising reliability, and that reputation has never needed embellishment. Number 1, John Deere 6068. John Deere answered the call for cleaner emissions and better fuel efficiency with an engine that would go on to define reliability for the next generation of agricultural workhorses. The 6068 diesel. Originally developed for tractors like the John Deere 6900, this inline six was engineered to maintain performance across varying conditions without sacrificing ease of maintenance or longevity. With a displacement of 6.8 liters, equal to 415 cubic inches, the 6068 offered a practical balance between power and efficiency. It delivered output between 130 and 150 horsepower, but its real value lay in the steady torque curve and ability to hold load at low RPMs. For field operations requiring constant drawbar pull or heavy PTO work, this engine rarely faltered. Mechanically, the 6068 relied on a cast-iron block, wet sleeve construction, and direct injection system. These design choices prioritized structural durability and thermal control, while also allowing for in-frame rebuilds, without removing the engine from the chassis. The robust cooling system, including a high-capacity radiator and belt-driven fan, ensured consistent temperature regulation even under prolonged strain. Fuel efficiency was another strong point. With its optimized combustion process and careful calibration, the engine maintained low consumption rates across a variety of load cycles. Operators appreciated the long intervals between service, straightforward access to key components, and the reliability of its rotary fuel pump, even in less than ideal fuel conditions. The 6068 diesel became a mainstay across multiple John Deere platforms, not because it was experimental or revolutionary, but because it simply worked. Year after year, season after season, It kept farms running with minimal interruption. Its reputation was earned not through novelty, but through sheer mechanical dependability. These engines didn't just power machines, they powered decades of farm work without giving up. If one of them kept your fields moving, or if we missed a name that should be here, tell us in the comments. Like, subscribe, and stay tuned for more hard-earned machine history.